So I'm just going to remind everybody that the session's being recorded today, and that we've started the recording now. So it's just you may have had a pop-up to provide your consent to be recorded, so thank you for that. And just a reminder for those that may have joined us just now to please ensure that your mics are muted, and if you do have anything that you'd like to share with us throughout the session, if you could use the chat. And we've got 2 people sitting here in the room with me that are monitoring the chat, as well as our guest speakers. We'll all try and keep an eye out for you today. So as I mentioned, my name's Tracey. I'm delighted to co-host this with Macquarie University, and we've got 3 distinguished speakers today who I'll introduce in a moment. Why isn't that working? But before we progress, the majority of us are based in Australia, and we're based in a diverse range of places in Australia. So I'd just like to acknowledge the traditional owners of the land of which we all meet today, and that we show our respect to their cultural links and heritage. So I'll introduce very briefly Martina, Abhay and Mauricio. They're 3 distinguished researchers from Macquarie University, quite well known, and we've got a really large crowd, over 200 and I think 230, was it, Angeline? 255 people have registered for this session. So I think that alone speaks volumes of how well esteemed our guest speakers are and how topical the topic that they're going to speak with us today is. So we're looking at a really robust way to review the literature, and our guest speakers will go through 3 different methods of a systematic literature review: Histcite and ResGap. So we'll roughly spend 10 minutes on each of the methods. If you would like to raise a question in regards to each one of those methods, we can try and monitor those throughout the session, so please post those on the chat and we'll try and monitor those. If not, save your burning questions to the end, because we have allowed 20 minutes for a Q&A. But bearing in mind, we have quite a large audience, so if you can put your questions up on the chat, we'll try and cluster themes, so try and cluster like questions together so we can make sure that we cover as much content as possible. So that's enough from me. I'd love to pass you over to our first guest speaker. So Martina, who would be speaking first?
Yep, so I'll be up first. So I will just quickly just jump to my relevant screen here. So hopefully I'm now sharing my slides with you. So yeah, as Tracey mentioned in the introduction, and thank you very much, Tracey and Angeli, as well for hosting us today. It's a great pleasure to be presenting to you today. So our focus today is to look at systematic reviews and essentially looking at a very robust and a very systematic view of presenting and summarizing the literature. So our team, Mauricio, Abhay and I, we have done quite a fair bit of work in this area. And as we progress, we are always trying to innovate in this space as well to see essentially how we can make these methods more robust, and also how we can introduce further innovations and also just further development into this field as well. So we'll be presenting some of our work today. Essentially the majority of what we are presenting today is based on this paper here, published in the Australian Journal of Management and on conducting systematic literature reviews. So this paper is essentially providing a summary of the main idea, the main methods, but we'll also give you a few other references to look at as well. In particular, if you'd like to see some additional examples for different types of literature review, because there's definitely not a one-size-fits-all approach. So depending on what you're researching, there might be some different alternatives, some different options for you. So the main issue that we're essentially looking at is this whole problem here, right? We have got so much research that's being published. There are thousands and thousands of new studies coming out every day. In our field, replication is often not encouraged. It's a little bit different for the medical sciences and other fields, but in our field, there is a huge emphasis on innovation. which also means that we see a lot of unsystematic proliferation of knowledge. Every study has got different variables, different timeframes, and so on. So that poses additional challenges with actually really understanding the progress that's happening in a particular field. And here, this is really this situation where systematic review can help to ultimately summarize and give a very good overview of what's been done and what hasn't been done, just to sort of see what do we already know about a particular field of research. So our colleagues in the medical sciences are very interested to know if any particular intervention is working. As you can see currently with the coronavirus vaccine, right? Everyone wants to know, is this vaccine working or not? But in our field, we are often not paying attention to this type of question. If we're introducing any particular innovation, if we are introducing an intervention, any managerial intervention or any type of other intervention, is that actually leading to the desired outcome? So the idea is with a systematic review to look at these types of questions and to produce a robust overview of the literature. So with a systematic review, and the type of review I'm focusing on here today is a standalone review, but you can also use these types of techniques here for your study, just to summarize a shorter review at the beginning of a journal article, for instance. But essentially the majority of what I'm talking about today is looking at a standalone literature review. The idea is to produce a critical appraisal and synthesis of all relevant studies. So which brings us obviously to the first question, how do we identify those? And I'll go through that in a minute. And the idea is really that we follow a systematic and a robust and a scientific approach here. So we want to limit bias, not just our own selection of some studies over others. Ideally, we also want to have a very good, rigorous way to identify the research and establish replicability. So someone else looking for this evidence should come up with the same data set, with the same studies, and ultimately with the same findings. And it should not just be a random collection of articles that you might have already saved on your computer or found on Google Scholar. So the idea is really to come up with a systematic and robust way to identify relevant research. What we often see in studies and in systematic reviews that are submitted for review as well is that there's often not a systematic approach in these studies. So there's sometimes just a cursory overview of the literature only. It's sometimes not clear how articles were selected for review, for inclusion, for exclusion. It's often not quite clear. So why were some studies mentioned and why were other studies not mentioned in a literature review? Important contributions may have been missed. And often we also found that literature reviews do really not provide us with a very good understanding of the field, the main theoretical contributions, and also important causal links that ultimately might be missed as a result of essentially not having a very, very systematic review process. So how do we get started? So for those of you wondering, okay, how am I actually going to get started with a systematic review? Again, these steps are detailed in our article in sort of with a little bit more information. So in case you miss some of these points here, you can also go back to our study to read up on those points. So in a typical systematic review, we would essentially go through the same sort of stages that we would have for any type of research study. So your introduction, your method, and they should be really detailed in terms of, you know, how have you located articles? What are the inclusion, exclusion criteria? How do we locate those types of studies? And then results will also show some elements today of how you can present results according to different visualization techniques and so on. And the idea is then also to look into avenues for future research, right? So I think that's really valuable as part of a systematic review, that you can really summarize what's been done, what has not been done, where do you see opportunities for potential future study, or what are important gaps that haven't been addressed yet. So I think systematic reviews are also a very nice way to provide some authoritative insight into a particular field of study and to give some guidance to researchers as well based on your findings. And then we'd provide with researchers with some conclusions and insights into the field. So I think this is a really important step for any type of systematic review, to really look into your inclusion and exclusion criteria, right? What type of literature, what type of articles, what is it exactly that you are going to review, right? What's the information that you are going to include in your review? And this should be really driven by your problem and your research question. So there's obviously a lot of evidence out there, so you might not just want to include every piece of evidence that you can find, right? So you really have to think about, okay, what's my main research question? What literature is related to that main research question? How do I find these articles? And importantly, do I want to include any type of what we call gray literature? So that could be books, book chapters, conference papers, reports. This can be much more challenging to do because that literature is often not collected in a systematic fashion in databases. Our recommendation is not to make exclusion criteria in a first step. So for instance, there might be some studies that you simply don't like, but the idea is in a systematic review, ideally you want to keep them and critique them rather than just deleting them, because that would essentially lead to a sample selection bias. So to give you some ideas here how a systematic review can look like, I've put up one of my examples here. In 2017, one of my reviews was published on the topic of organizational resilience in the International Journal of Management Reviews. And in that particular article, I looked at a very simple but challenging question: how is the concept of resilience actually defined? So in order to introduce a robust but simple search strategy, I decided to search for this abbreviated term resilient with the asterisks, which essentially gives us word variations, resilient, resiliency, and so on. In my particular case, I limited the search to literature of business and management because this is what I was interested in, right? But again, depending on your particular research question or field, this may or may not be appropriate. So you have to make those decisions, right? If this is not your field, then ultimately you might have to consider limiting yourself to a different field. Having said this though, there can be problems with just limiting your search to articles or journals published in a particular field, because increasingly we see interdisciplinary research coming out, right? So important contributions might also be published in other journals. Consequently, it's super important to do a cited reference check to see, is there anything else that we should be including, and also run this past colleagues and other experts in the field who might be able to point you to other important contributions as well. So for those of you not familiar with the concept of a cited reference check, that essentially means that you look at all the stuff that other studies are citing to see, is there any study that I might have missed and should be including in my systematic review as well. So you can already see systematic reviews are not a very easy and straightforward sort of process. They do require a lot of work, but I think it's also quite a nice process to go through if you really want to inform a field of research. So ultimately, once we've decided what to include, we also have to think about what to exclude, right? So especially if you search in databases like the Web of Science or Scopus, you will always come up with studies as well that do not fit your particular research question, because simply they're using a particular word or particular concept, but the study might not really be on that particular concept. So you have to make sure to go through them. What we normally do is that we assemble a team of researchers and we do triangulation on this. So we would have 2 or more researchers going through the list of articles that we found through our initial search to then say, do we want to keep this particular article for inclusion or do we not want to keep it? And we would compare the results across the team. So it's very much similar to triangulation in qualitative research, for those of you familiar with that. So the idea really is that we want to introduce robustness into the method as well. So it obviously can't just all be automated, right? You still have to have some human judgment. But I think this is really adding robustness to the findings. So in terms of analysis, right, there are multiple different ways how you can present the findings. Normally, before I jump into the analysis, I would always do a bit more of a scoping exercise, right? Go through the literature to see what has been done, what hasn't been done. I think it's really important as well, before you write your own systematic review, to check, have there actually been already existing reviews, right? Because, you know, I think then you don't really want to go and replicate what's already been done. So that could be an exciting avenue here to build on already existing research and to see if your findings actually compare to what's already been done, or if you can add some new insights into the field of study. I think it's also important to see if you can see any main themes in the literature, right? Any main gaps, anything else that you might need to include in terms of literature or concepts, right? So we normally actually do spend quite a fair bit of time on these steps to make sure that we've got a really robust idea of what's happening in the literature. People sometimes seem shocked when I say to them, I'm actually reading a large part of the literature when I'm writing these reviews, right? But I think it's really important to do that because, you know, I can't really provide a good and systematic review about a topic if I'm not really diving a little bit deeper into the literature. So for my resilience review, I definitely made sure that I was going through and reading these articles, or many of them in detail, for others at least the abstract and the main findings, right? Just to make sure that you get a really, really good sense of what is really happening in this field of study. So we are talking here a little bit in the next section just about one way to present your findings, and this is an approach we have used for some articles, and this is the use of citation maps. So there are different programs out there, right? We can't go through all of them today. You will definitely see there are other types of software packages out there that can help you as well. I personally have done quite a fair bit of work with Histcite, which is one possible approach to visualize bibliometric data. So it provides you with a way, and I've got some examples on the next slides as well, which will make it clear what this does. It provides you with an opportunity to visually map the literature. So what articles are actually related to what other articles. So it's essentially a little bit of a map of a field of research. Some fields have got a lot of articles, like literally thousands of articles published. So that makes it a little bit challenging to produce these maps because they become very dense. So you might want to select a particular number of articles for display, right? This method then allows you to identify records based on their citation count as a proxy for their importance, which may or may not be an accurate description. So it's always very important to keep that in mind. This can be slightly biased towards older publications because obviously older publications attract more citations over time. So just keep that in mind for that particular method. What's also very important is to look at data cleaning, right? These programs don't just simply work on any kind of data set that you feed into that program. So normally before we use these programs, we would make sure to do a very robust data cleaning exercise to make sure that duplicates are removed, that citation records are unified, because there are often some differences in the records, you know, how they're presented, spelling mistakes, author names are treated differently and so on, especially if author names have got hyphenations or different characters in them, right? So it pays off to spend some time here to make sure that these issues are being cleared. So the method that we are showing here, it's ultimately based on the work of Eugene Garfield. And a lot of that work is also underlying algorithms such as those used by Google search these days, right? So it's essentially a very similar kind of idea to see what's linked to each other and to make a judgment then ultimately what kind of results we want to display. The Histcite version is unfortunately no longer supported, but good news is the old version still runs on the current Windows system. It's actually running pretty well. Histcite, and Abhay will talk about this as well, has got a lot of functionality that R has got as well, but in order to use R, you have to be familiar, at least to some extent, with the R language. So for those of you who are not so much into coding, I mean, Abhay is going to fix that. He's going to convince you that you need to learn to code, right? But for those of you who might feel a little scared about this, this is a more user-friendly interface here. So what does it look like? It essentially looks like a citation program, right? So you can upload your citations into it. This is just a sample data set here, right? That has got some data on citation analysis. So you see the date, author, journal, you see the local citation count. That means the number of citations to the paper from within that body that you have selected. And you also see the global citation score, which means all citations that the paper has attracted globally from everywhere, right? So it can be a very, very nice way to see what papers have attracted a lot of citations and essentially what's been deemed as sort of important in the literature. And I know that citations are only one measure of importance here, so I'm very much aware of that when I say that. The program has got a very nice option as well to conduct a cited reference search. So essentially it shows you references that you might have missed. So this is the cited reference tab here, and you can immediately see the citations underlined in blue. They're already part of your collection. Those that are not underlined in blue, these are citations that you might have potentially missed. And these are articles that perhaps you might want to look at because they're obviously highly cited by other articles. We do have additional material on how to do this if you're interested, so we can definitely send you further information here as well. So the nice thing is this program has got a graph maker. So essentially this will produce this map of how different articles are related. So every article is represented by a dot and their citations are represented here by arrows. So you can then see what this map of research looks like. Who's been citing who? It's just essentially the who is who of research basically here that you can produce, right? So, and as I said, for larger fields, it might make sense to set a cutoff somewhere, because if you try to visualize 2,000 papers, this becomes incredibly dense and you will not be able to see much in terms of a research field here. So to give you some ideas how this looks like in practice, so this is from one of our reviews on sustainability. So we've mapped all the literature on sustainability. I think this had probably over 3,000 articles in it, right? So we have picked the top 50. I think we've had to go up to top 53 because some of them had similar citation counts. And this type of analysis then allowed us to show how the literature was essentially developing in terms of different fields of research, which we've then shaded, and I've just sort of overlaid that here over the citation map, and you can see the different fields of research here. Another example, and this is also published in the AJM paper, so we looked here at articles published within one particular journal to see what's been happening there, and you can see one special issue stands out here essentially, where we see a lot of density around citations in that particular field. So it can be really interesting to identify different research streams and different research contributions as well. As I said, one last thing to keep in mind: citation mapping gives emphasis to earlier papers as they had more time to attract citation, right? Obviously, something published in 1970 had 50 years to accumulate citations. So these papers are more likely to show up in terms of citations. Consequently, it sometimes pays off to limit yourself to the last few years, or in addition to scan papers that have only just been published, to get an idea of future research directions as well. And ultimately, I think systematic reviews can be a really nice way to change minds. You can probably always see these systematic reviews coming out if a glass of wine a day is good for you or not. They always seem to come to different conclusions, but I really like the ones that say one glass is definitely very good. So I leave you with those thoughts, and I'm going to be handing over to next in line, which I think is Mauricio, and he will tell you a little bit more about different ways of conducting systematic reviews. So thank you very much.
Thank you, Martina.
I just have to unshare. There we go.
Thank you. So I'm super excited to be here. I'm glad that you could join us, and thank you for that introduction, Martina. So one of the things that I have, that I'm looking at is rest gap. And one of the things that we as researchers want to know is, how is research evolving? So we might be interested in to see, which topics are gaining more attention or perhaps even less attention. We want to see research themes that are evolving, that are becoming bigger over time. We want to understand gaps and opportunities. Overall, we want to have a handle of how the field evolves. Now, bibliometric mapping, which we'll get to into this in my talk and then a little bit later with Abhay, they try to map a field by discovering the structures of knowledge in a field. So these are known as case structures. And they try to look at, say, for example, the intellectual structure of the field. And this is done, as Martina just showed us, with, say, for example, co-citation analysis or citation analysis, for example. You can also look at the social structure. So who's collaborating with who? Who's writing a paper with who? And finally, you can do a conceptual structure analysis. And this can be done by looking at the content of the papers that are being published in the field that you're interested in. Often in bibliometric, this is done by looking at keywords, and Abhay is going to show us a little bit about that, I hope at least. It can look at abstracts and titles. However, there's some limitations with that, and we're going to talk about the limitations in a second. There are a number of tools that help us with this that may help us analyzing the content. If we use bibliometric tools, we can use things like CiteSpace or bibliometrics. We can use things like Leximancer, or we can use LDA, which if you have not heard of it, it's not a problem at all. It stands for Latent Direct Allocation, or other text mining tools. Now, in my experience using these tools, I've always run into the same issue. A bit of limitations that I've ran into that I want to share with you, and then tell you how I've thought of a way of overcoming these limitations. So let me start off with an example, right? So let's just imagine that you want to look at the topic of service level agreements. If in a paper you have the term service level agreement, or the plural service level agreement, or SLAs or SLA, what you're finding is that because of the way that these softwares look at the words, they're going to be identifying 6 different concepts. So the word service is going to be one, the word level is going to be one, agreement is going to be another one, SLA is going to be another one, agreements, forgot about that one, the plural is going to be another one, and finally you have SLAs. So there's no ways of really kind of like aggregating these concepts into one and saying papers are talking about this one thing, right? Another issue that you may find is that some of these topics appear often in papers that you may be looking at, and they're not separated enough. So let's say, for example, that you're looking at the term IT service management. You're trying to investigate how IT service management has evolved over time. Well, if we look at it again in words, as these softwares do, IT, you can find papers that actually mention the word it. And so there's no way of distinguishing, with these tools, the differentiation between IT as information technology and the word it. Service can mean many things, and management, if you're looking, because we're talking about business and economics, management is often mentioned. So there's no way of really capturing this term, IT service management, and other ways it can be mentioned, and just keep it as one term. Except that in recent times, in information retrieval, people have actually been looking at ways of finding what are the meaningful mentions in a text, right? And then kind of like disambiguating the different ways of mentioning this text into one way. So let me give you an example. So Paris is the capital of France, just as an example. Well, what Paris are we referring to? So we've identified 2 terms that are really critical to this sentence, Paris and France. Well, when we talk about Paris, what Paris are we talking about? Are we talking about Paris Hilton? Are we talking about Paris, New York? Or are we talking about Paris, France? And when we talk about France, are we talking about France, France River, Radio Station France? And so what entity linkers are going to do is going to disambiguate and link these terms into one kind of like term, so that even if there's variations of the way that people, authors, can refer to this, it's always going to be linked to the same term, which is great. Let me give you an example just in case this has been sounding really weird up to now. Let's just imagine this example, right? Michael Jordan was a basketballer for the Bulls. Jordan played for the Dream Team at the Olympics. So what entity linkers are going to do is they're going to identify what I call topics. And so say, for example, the term Michael Jordan here is disambiguated, basketball is disambiguated. And here's where it gets really interesting with the usage of entity linkers. So if you look at the third topic identified, it actually reads Chicago Bulls. Yet in our text, we never mentioned this term, Chicago Bulls. We just mentioned the Bulls. So it's understood the context, and it's understood that when we're talking about Michael Jordan, we're very likely to be talking about Chicago Bulls when we refer to Bulls. So it's adding a little bit more of information. Same with the next term, which is, we talk about the dream team. Perhaps that's, colloquially how we can understand this term. But, a disambiguated way of understanding what the dream team is, it's the 1992 United States men's Olympic basketball team. And when we talk about the Olympics, the overall topic that we're talking about here is basketball at the Summer Olympics. So through the usage of entity linkers, we're disambiguating some of the terms that, may be lost in context, and we're establishing these links to terms in very unique ways. Let me give you one last example before I start showing you opportunities that we have by using RESCAP. So we've heard of the Homo sapiens. There's many ways of talking about this. So these ways of referring to these are called binomial nomenclatures. And there's many ways of referring to this term. Actually, I outline 1, 2, 3, 4, 5, 6 different ways, 7 different ways of referring to the same thing. So what an entity linker is going to do is that it's going to refer to, if anybody in a paper mentions any of these, it's just going to standardize it to this way, which is great, because what we want is, we don't want authors to once in a while refer to Latin name or binomial name. We want to link it always to the same term. So we have the opportunity here to overcome issues associated with homography and disambiguation, which can lead to some really interesting opportunities. What I've done with RESCAP is that we can look at burstiness. So burstiness is, and if you've looked at the paper, you've probably seen this graph, is to understand when a topic just kind of like explodes. Like researchers are now looking at this topic has become hot. And what we can do is then say, identify topics that are currently hot. And say, okay, in current publications, we have seen more people talk about, say, for example, the board of directors and the importance of the boards of directors. And with an image like this, you can gain an understanding of what has happened in the past, what's happening right now, and you can almost begin to make deductions about what are going to be some of the topics that are going to be happening in the future. Another thing that I've done, and if you've looked at the paper again, you would have seen this, is that you can do networks. You can see how topics are connected. What are the main nodes? And how the topics connect. So this is known as a maximum spanning tree. And what it does is that it will only connect to a topic, it will only have like one branch. And that helps connect topics and helps us clearly understand how are terms being used. Like if, say, for example, employment is being spoken about, right? We might talk about then topics such as perception, and then if we're talking about perception, then gender equity are topics to be highly connected together. What we can do with that as well is that we can do a maximum spanning tree with focus over time. So in a paper that I've published recently, we looked at a journal, the Journal of Accounting Information Systems, and what one can do is you can look at the tree and also look at the most recently mentioned topics and those that are not. So that's kind of like an added element there. In a recent paper as well that I've published, we did this timeline. So this is very similar to the image that I showed you at the beginning. This one's just a little bit easier to see. And in this paper, we looked at how environmental accounting was being mentioned both in accounting research and in non-accounting research. and we did a comparison of the two timelines. So if you want to look at how we've implemented that, that's the reference. The final example that I want to show you today that can be accomplished using this approach is that what you can do is you can have two areas that are talking about the same topic. So we looked at the top 4 environmental science journals, and we looked at a number of management journals. And we wanted to see, okay, in this topic, how are people referring to the different topics? And we identified topics that were very frequently, so this is frequency, for very infrequent to very frequently mentioned in environmental journals versus infrequently to frequently mentioned in management journals. And you can do a comparison of what is salient in one area, what is salient in the other, and what is important to both. What are kind of like the, if I can put it in certain terms, lock words, or words that are being used in equal frequency to both areas, kind of like the common language. These are some of the approaches that I've used to look at the literature, the academic literature, and even the gray literature, and show differences and show what's hot in an area, and also be able to map it. So that was my talk about RESCAP. I will now pass it on to Abhay. I'll stop sharing if I can. And over to you.
Thank you, Mauricio, and thank you, Martina. This is quite exciting. There's so many people who have joined. I'll share my screen now, and I'll introduce you to how to conduct systematic reviews using R, and I'll talk more about it. Once I get started talking about R, you can't stop me, but I'll try and stop. All right, so how to conduct systematic reviews using R? To understand that, we need to first talk about R. I'm sure some of you are already aware of what R is. And after this, you should be more aware about R. What I'm going to do today is I've planned to do a tiny bit of hands-on so that everyone can see how this happens in operation, rather than just me giving you a sort of a PowerPoint presentation. What we'll do is we'll quickly get over this PowerPoint, and then we will switch to R, and I'll show you an example how this can be done. So what is R? R is amazing. R is awesome. It's a very popular open source statistical, and I should say now data analytics programming language. I've been using R for almost 11 years now, and since I started using it, my research has evolved around it, and now I'm specialized in data focused research. And whenever there is data, I can use R to explore it. Just a fun fact, these slides are also made in R. So I've already created a GitHub repository, which I'll give you the address soon, where you can go, you can download the whole material. So there was a question previously, if you want the slides, you can go online and get them. So why we want to use R? It's not just for systematic reviews. If you use R, and I think Mauricio uses Python and R as well. I'm trying to learn Python right now, and I've been using R for some time. Either of the languages, once you start using them, you can use them for various research purposes. It's not just conducting the final stage of your analysis, but they help you right from the beginning. When you download the data, you collect the data, when you have to pre-process it, when you have to clean it, and after that you can visualize it, you can do analysis on it, and these days actually you can do the whole documentation in it. There is a term which is getting popularity. It's called reproducible research. In reproducible research, there is a demand these days that you should be able to share your routine. You should be able to share a document in a way that the reader can replicate it. And R really helps with that. You can watch this video. So what about systematic reviews? Systematic reviews, there are so many packages in R which enable you to do that. I've mentioned some of them on this slide, but one of the most popular ones, if not the most popular one, is bibliometrics. Bibliometrics has evolved quite a bit. When we did the first paper with Martina and Mauricio, it was it had a few less of functionalities, but the recent version even have more functionalities. So they keep adding functionalities based on the research in the systematic literature review domain. People have this tendency to make you use what they have invented. So what they do is they create a code and they upload that. That's called a package. A package will give you functions which you can use to replicate their method. So that way, it's really good. And it's free. You don't have to go and buy any software for this, so you can use that too. Bibliometrics is by far the most popular one, and they have good resources to help you. The help provided there is pretty amazing. I've opened that web page already so that I can show you. Here you can see all the documentation. There is a very nice introduction to it, and you can go through that. They show you how to collect the data, how to generate the BibTeX file or even a text file or a CSV, import that, and then do analysis on it. So all the resources are available here. So if you even are a beginner in R, you should be able to do this. So we'll use bibliometrics for the example, but if you're scared of R and you haven't had a chance to get started with it, this is just a shameless plug for my upcoming 2 workshops on R, which are actually the first one is on the 15th of September, and where I'll go through how to get started with it. So how to install it, how to get started with importing data sets, how to install packages, how to do a bit of visualization. And then on the 24th, we'll go through some use cases in data analytics space. I'll touch on a research use case and one industrial use case. The registration link is available here. Spaces are still available. Make sure if you have the time and if you want to learn more about R, you register. The resources which I'm going to use, they are available on my GitHub page. So I've created a systematic review folder there. You can clone the GitHub page if you like, or you can pull it, or you can download the whole thing. It's up to you. And there are markdown files in there which you should be able to replicate. So there are main results here, but what I'm going to do, I'm going to jump into the R markdown file so that we do that in real time. And I'll show you how easy it is to go from R, a markdown file, to a document which you can share among yourself. So all of you are familiar with R. You'll know this RStudio interface. RStudio is like the Rolls-Royce of GUIs for R. If you are using R, you want to have RStudio. RStudio is almost a standard now. You can use R from base R GUI, but that's not that helpful. You can even use from other coding GUIs, even VS Code supports R, but RStudio by far one of the best GUIs ever for R. When I started coding R, it was not there. So I had to do scripting in a way where I was typing in text documents and then evaluating it. It was really a pain in the backside, but now it's so easy. And with Markdown there, Markdown lets you conduct everything within a notebook, then generate a document from it. So this is what I've done. I have created a Markdown document, which I've shared so that everyone can replicate. And for reproducibility, I decided to use the data which is already provided in the bibliometrics package so that everyone can have that. If you want to download your own data, Web of Science is the easiest way to do this. So my sharing stopped in. Okay, sorry about that. I'll move this bar. So in Web of Science, you can go to search. You can search. For the fun of it, I was searching for systematic literature review while I was trying to create a search for you. And I was just doing that in the title. Once you have done that, and if you are from a university, most universities have access to this, so you should be able to do that. In here, what you do is you go to export, And I advise to export this into a BibTeX file. If you are not familiar with that, you can export this into a CSV or even in an EndNote. Bibliometrics provides you a way to import all of them. So I'll go to other file formats. I want to export 500 records, but when we are doing a bibliometric or a systematic literature review exercise, you want to export full record and the cited references as well, because you want to see what people are citing. And if you don't export the cited references, you will not be able to create those networks. And BibTeX, if you say export, it will give you a file which you can directly import into R. All right, going back here. There are some options which I've used, and just to point out, you may need to install some of these packages when you use them, but once you have installed them, this file should run pretty well for you. I'm using R 4.0. So some of you, if you're using an older version of R, you may need to update your R. So what's basically happening here is I'm creating this analysis using the inbuilt data set. So first thing, I'm going to import the data set. So data is scopus collection. This is a scopus collection where they searched bibliometrics in the title of the articles and downloaded all the articles from 1975 to 2017. First thing you want to do with the data set is you want to know the basic characteristics or the summary description of your data set. How many articles are there, if they are categorized by type of the articles, and so on. The main analysis in bibliometrics starts with the function called biblioanalysis. The first argument to that function is the data which you have, and then you have to specify the separator. Separator is the separator which separates your authors, which separates your keywords, and it's specific to the way you downloaded the data. You can run the whole chunk here using this play button, and it runs. It's just going to take some time, but once that's done, we'll see a table of summary information. I'm using a package here called Pander. Pander interacts with Pandoc. What Pandoc does, Pandoc creates tables which you can put in Markdown, you can put that in PDFs, you can put that even in Word files. Once we're done, I'll generate the Word file, which is already uploaded on GitHub, but I'll show that in real time. So the main information we get about our data is the time span, the sources, the books, etc. Number of sources. It's come from 280 sources. How many documents are there? There are 487, and so on. You will also see a breakdown. How many articles are there? How many books, conference papers, etc. Now, if you are doing this, I would really recommend importing the data and start working on it once you are really happy with the search you have done. And you may need to do some of bit of pre-processing within, let's say, EndNote or any BibTeX software you're using, because sometimes there are some missing values, some missing information which the search engines don't give you. You may need to manually fill that. So do all that first and then import it so that you get minimum errors. None of the search engines for searching literature are actually 100% perfect, because some journals may not give some values. That's why we need to check the data. Now, if I want to just know what are the productive authors, I can just create a table. Basically, what I'm doing here is from the summary object here, I have extracted that. Summary object is my S1. So if I want to do S1, I can do most productive authors. And these are the top 10 authors. Number of articles they have, and so on. You can do this, create a table out of that. It creates a table as well. Now, what were the most cited papers? I saved most cited papers already. You can create a table of that. Now, the first, which is the top most cited paper in this data set, had 331 citations, almost 22 citations a year. So this is actually a very highly cited paper. Now, not just tables, these days you want nice looking graphs. You can create them as well with bibliometrics. Simple plot function creates a lot of graphs which you can visualize and analyze straight off the back. What I'm doing here is I'm saving them in a variable as well. Why I'm saving that? So that I can extract the graph I want and the way I want to visualize it. And very nice thing with this package is, and it's really good for visualization, that the most of the graphs which it returns are returned in a ggplot format. So you can extract that whole graph object and modify it. I'll show you in a second what I mean by that, because I modified one of them. After this, if I want to change anything on the graph, because let me show you. This is the most productive author graph. It is standard what it returns from the package. Here you can see it's in an increasing order. What if I want to have the most productive author on the top? Because it's returned as a ggplot object, I can change that. I can change it within the code, and it takes one line of code. If I want to try and do this, export the data into, let's say, Excel, and then do that all over again, it's going to take me a lot of time. And that's one of the good things with coding. So I want everyone to start coding, because that's the future. So what I've done here is I've extracted that. And once you extract that, you can change it. You change that the way you want. You can change the labels here. You can call it something you want to call, and also the Y label or X labels here. So for example, here the default is N of document. You can write completely number of documents. Now the second graph which we have is the most productive countries. In this data set, USA has the most number of papers. That means the authors who are publishing in this field are mostly from the USA. Then scientific production, and how many average citations we are getting per year. So you will see that we have a jump in the recent years. Now, what if we want to see how many articles are top 10 authors were publishing each year? We can get a graph or an analysis called production over time. What it does, it plots the number of articles these top 10 authors, or top 20 or top 50, whichever you decided to go for in the beginning, they were producing every single year. And here you can see that our topmost authors, the top author actually started publishing in 2011, actually even after that, 2012, but they are publishing quite heavily since then. What if we want to visualize the network of these authors or countries and so on, meaning who's working with who? Are we collaborating cross-country or cross-authors or cross-universities? We can do all that. We can visualize that as well. So this is information through data. We collected the data and we can visualize a lot from that. So this here just visualizes how people are collaborating. You can see that United Kingdom and USA, they are collaborating. There are authors coming from here, but everyone is collaborating with them. You can change the size of that. You can change the type of the graph as well, and see which one fits better for the visualization you're going for. Now, what if I want to see a relationship between few fields in the article? Every article has few fields. For example, authors, keywords, abstract, JEL codes, for example. What if I want to see what is the relationship with that? For example, what's the keyword? Who's publishing in those keywords, and which years they have published or who they are citing. So we can create that with 3 fields plot. It's also a Sankey diagram this diagram is called a Sankey diagram. It's interactive. If you hover over a link, it tells you where it goes. It takes a bit of time, but once it's generated, it's quite informative. Now, Mauricio already talked about how you can generate topics, how you can have a burstiness analysis. So I'm not going to go to burstiness analysis because Mauricio's program does it the best. What else we can do with bibliometrics is we can do, for example, cluster analysis. We can see what are the main clusters in the keywords or in the abstracts of the papers you have. So this sort of analysis is categorized under core word analysis because they take the words occurring together and then they analyze it. There's some graphs which you can generate, which I've generated here, and you can plot them to analyze the main themes in your data set. So you can see here that if we do a cluster analysis, we get some clusters. almost 4 distinctive clusters. And then you can do a dendrogram of that as well to know what kind of topics. Topics, when I say, I mean keywords or the words from the abstract. They are more common in the articles you have. What if you want to analyze the author collaboration network? Who's publishing with who? You can do that too. So we can see that this is a big network. These around 10 authors are publishing quite often with each other. That's why they're related. Another thing which is a new function here is called a thematic map. What thematic map does, it is based on an article published in 2011. It creates your themes based on the keywords or in the data you have. It identifies them as motor themes, emerging themes, well-developed themes, or general themes based on the quadrant they are in. You can create that as well. Once you do that, you can plot that, and then you can identify the themes which are maybe the core themes in the field, or maybe which the themes are discussed all the time, or themes which are not discussed that often anymore, depending on the quadrant they are in. This one takes a bit of time. Now, for example, this is interesting because in here you can see that information science, bibliometric analysis, they are coming as emerging or general themes which are there. And this is a bit biased because we search for that bibliometric anyway in this data set. But if you have a general data set where you are looking for a few phrases together, this is quite helpful. Now the best part, you have a GUI for this. You don't have to actually just code this. So when I said you should learn coding, you must learn coding still. But if you don't want to, the bibliometrics has something called BiblioShiny. And it gives you a GUI. It's going to take some time, but it will load. And what it does, it lets you import the data and do this whole analysis within the web page. So you can import the same data there and do this whole analysis there. But coding is better because what I'll show you now is I can convert this whole thing into a document. And then I can share with, for example, if I'm a PhD student, I want to show this to my supervisor. I can do this all in a markdown document, and then I can generate a file right there and send it off to my supervisor to have a look, where they can have a look at the code, the analysis I conducted, and the output I got. So you just have to go and knit it. I'll knit this to a PDF, and we'll see the output in real time. It just takes a bit of time. So while that's happening, I'll show you the GitHub page I was talking about. This is the GitHub page, and I have saved all the markdown files here. And for the notebook, the markdown files for the slides are not there, but the slides are under docs. So you should be able to get the HTML for that. But if you just want to view this, you can use this link to view the slides. Should have converted this to HTML, which is a bit quicker. And at the same time, if you convert this to HTML, you can host it on GitHub like I did as GitHub pages, which works out even better if you are just using GitHub for everything. Here you go. Once you do that, you have the whole document. Everything which I did, it's here. Even the tables, I can caption them. So it's a document which everyone can understand. All the output is there. All the code is there. So if your supervisor or if yourself, you're a supervisor and your students are using R, you want to check their code, you can see that too in the document itself. The diagrams are there. Everything is there. This is easily done and you can send it off. So this is my part of the presentation. As I said, I like data and R, and I will advise everyone to pick up R, even Python, and start learning how to do data analysis. This will even make you do bibliometric analysis. Thank you.
Thank
I
you.
stop the share now.
Thank you, Abhay. Thank you, Martina, and thank you, Mauricio. That has been fantastic. I've read your paper in the Australian Journal of Management 3 times in preparation of this, and also as part of my work. But I think that it's proven to me today that hearing the insights firsthand from the authors and seeing it in real life really does help cement some of the knowledge, and also opens up new questions, as we've seen through the chat. So just outstanding presentation. Thank you. Very impressive. So as mentioned in the chat, we have kept record of all the questions and